Hello, everyone, and welcome to our Predictive Analytics in 30 Minutes webcast. My name is Candace Taylor, and I am the Director of Marketing for the Cresco International, and I will be the host and moderator for today's webcast. We first want to start off by thanking you all for joining. David Zyla, Predictive Analytics expert with IBM, will be providing some really valuable information in the next 20 minutes or so on predictive analytics. A quick note I wanted to mention before the webcast starts, we will send out a link of the recording to everyone as soon as it is available. Our agenda for the webcast today, I will briefly review who Cresco International is, and I will then pass the floor over to David to start a demo on predictive analytics, and then we will have closing remarks. A brief introduction about Cresco before we do get started. David, if you could advance the slide, please. So Cresco is a premier IBM business partner and business analytics company that provides consulting services, IBM analytics software, training, support, software management and renewals, as well as cloud solutions. Also, you'll see on the next slide a list of our clients. We do provide Cognos training solutions, implementation of business analytics software, and consulting to cross-industry organizations. At this point, I do want to pass the floor over to David to start his portion of the demo on predictive analytics. David?
Perfect, thanks Candace. And I'll just make sure that as I cut over here that you can see my screen properly. And let me know if you have my new desktop on the screen now.
Looks perfect, David, thank you.
Perfect. Well, thank you, Candace, and thank you, everyone, for attending today's webinar. In the upcoming demonstration, I'll walk you through the process of creating a predictive model, along with deploying the results back to your corporate data repository. Now, we know that predictive analytics is a powerful discipline, and I really hope to impress upon you how quickly you can gain insights with IBM SPSS. For today's demonstration, we're going to walk through a typical marketing example. I'm sure we can appreciate that sending out glossy mailers or even the time to make a phone call to potential customers can be a costly proposition. We're also using a marketing example because there are attendees from multiple industries on the phone, and this example is something that most people can usually resonate with. So what we're going to do is look at a marketing example in terms of sending out a sample mailout, and we want to use this as a subset to determine who we should mass market this ad to or this campaign. So to start off, what we have in front of us right now is SPSS Modeler. This is the interface or the canvas for building a lot of these predictive models. Now I really want to keep this as a simple process. For those of you that are familiar with data warehousing solutions, building data marts, data warehouses, at the end of the day we're going through similar exercises that your IT and business departments go through on a daily basis. The ETL process of extract, transform, and load. We're doing the same thing with building predictive models. We're sourcing data from one or more systems, pulling it together, possibly cleaning it up, preparing it a little bit, and then running it through some predictive models. So these are predefined algorithms, statistically proven methodologies across the industry that we're leveraging within the framework here, running it through these algorithms, and then sharing the data back to a corporate repository, Excel interface, but that's the typical flow that we're going through today. So in this canvas in front of us, we have multiple tabs here to really keep the process as simple as possible. On the Sources tab, we have several options for sourcing our data. If you're connecting to a DB2, Oracle, SQL Server database would be the first option, flat files, text files, CSVs. For those of you that are running Cognos TM1, budgeting and forecasting application, we have the ability to read from and write back to your TM1 cube. This is a really powerful option for building a predictive forecast, leveraging time series analysis as well. So there's some synergies that exist within the BA portfolio. So various sources. What I'm going to start with today is a statistics file. So statistics is sort of the sister product to IBM SPSS. So simply I double-clicked my node and I brought it over to my canvas. In this case, we're going to look at some customer data. So this would be something similar that you would get from one of your internal CRM systems. So just by running it, we have relative, straightforward information here. Again, this data set represents the sample mailout we sent to a random selection of customers. Each one has a particular ID here, and we have attributes and demographic information. So what region were they in, what customer segment, which talks about customer segmentation as well, how many times they visited the website, average spend, age, income, so on and so forth. What the important column here is this final response column. So of these mailers, what we really want to find out and track is these individuals that responded. So who responded and who did not respond. So the typical approach, prior to predictive analytics would be send out a mailer, get the data back, and say, oh, it looks like region XYZ is good, or this age demographic is who we should target it out to. What we've seen, though, is predictive analytics and these statistical algorithms can allow us to be much more accurate and refine our messaging and the target audience. So I'm going to go ahead and click on OK and have that added. So again, I can simply do a preview to make sure that everything is coming in properly. What I want to do now is just to give you an idea of the type of data that we're looking at. So I'm going to go ahead and look at one of my graphing nodes. So again, a series of graphs that are available to me. And I want to go ahead and wire up a distribution node. So simply double-clicking this joins the two together on my palette. So the data is being sourced from my first source node here, and it's flowing over to this next node. And in this case, what I'm interested in is this response field. So once I go ahead and run this, you notice that I have a visualization on the screen. This tells me the breakdown of those that did respond and those that did not respond. So I can see in this case, it's 804 individuals who responded to this campaign. And this is the group that I really want to focus on. And so this is going to be the focus of my analysis going forward. So that's one node. It's not a key node, and the way this data flow, it doesn't really matter which direction it goes. You can be as artistic as you want with joining these nodes up together. So that is the response. So similar to working with whether it's Excel or databases, you have to define the type of data that you're working with. So if it's a string, an integer, a date column, depending on how you identify your data determines the types of operations that we can do on it. So in this case, I added a type node, again double-clicking, and it automatically wired it up to my data stream here. So in this case, this ID column, it's really not useful. It doesn't add any business value. It's just an internal reference that we're using. So I'm going to go ahead and flag this as my record ID. And the other data point here is that we're really interested in this response field. I want to change the data or the measurement level. In this case, it's a Boolean flag, yes, no, whether or not they responded. And in this case, this is probably the key here to predictive analytics, is that I want to go ahead and flag this as my target. So I want the model to analyze this response field and determine what series or what combination of these other fields has a real driver on predicting who's likely to respond to a campaign or the next offer I'm going to make. So simply click on OK, and now I have that wired up together. So let's do a quick audit on our data. We know from history that approximately 80% of analysis, or 80% of a project time can be spent on cleaning up your data. So what we want to do is give you the tools and processes to quickly evaluate the quality of the data that you're working with. So in this case, I have all 13 fields. I want to go ahead and run this. And very quickly, it's gone ahead and run this and given me some indication as the type of data that we're looking at here. So ID is a continuous field. This is just that integer that we're looking at. It's an arbitrary number. And here we can see our region. So a nominal data field, minimum value of 1, maximum value of 3. But the importance of this is to give you a visual representation of the type of data that you're working with. Probably sex or gender would be a good field here. We typically would expect 2 fields, male, female, M, F. What often happens in data, addressing data quality issues, is that it may be inconsistent. Uppercase female, lowercase male, and every time you have a different entity or a different record, the model is going to treat that as different data point as well. So here we really want to gain some insight into the data so we can take steps and clean it up as quickly as possible. In addition to that, we have the data quality field here as well. And what's interesting here, or what is of importance, is the outliers and extreme outliers here. So everyone's going to cringe when I talk about statistics 101 here, but this goes back to your standard deviation, looking at your outliers within 1, 2, or 3 standard deviations. And what's interesting here is that we call out outliers and extreme outliers here. So what are on the extremes of your normal distribution? And so sometimes this could be poor data, but other times this could be anomalies or things that you're very interested in or things that you want to ignore. By assessing the quality of the data, you can take the steps to clean it as soon as possible and take the steps to address it. We really want to give you the tools to clean it up as quickly as possible. So that's the data quality, that's the data audit that we put together as well. So moving right along here, let's get a visual representation of what's going on. So I'm going to go back to my graphing node here, and I want to create a web plot. Now, web is just basically drawing lines between your data points that intersect with each other. So in this case, I want to go ahead and select all of my fields and go ahead and run this. So this is just to articulate what's sort of happening under the hood here. So this type of diagram is basically saying that, okay, for those that responded with the sex of female, how many were married or had no kids? And basically, the thickness of the line indicates how often those relationships or those records occurred together. So as I move the line here, you can start to see that we have some records being identified in darker blue lines. This is a similar approach to what we would do with market basket analysis. At the end of the day, you're trying to find out what products go together in a market basket. We're drawing a line there to identify those relationships. So in this case, I'm really interested in, I'm not interested in all relationships. I'm only really interested in those that responded. Now they want to show the positive values of those that did respond. So when I go ahead and run this now, I see a little bit more insights with regards to those that responded. Now I can see here that some trends between customer segments, whether or not they own a car, marital status. But at the end of the day, this is still more or less a manual approach. We're trying to manually, plot the data, gain some insight into the relationships, what's determining who's going to respond to a campaign. So this is just to illustrate sort of a brute force or a rudimentary approach to coming up with a predictive model. So now we're going to jump into sort of the meat and potatoes and the real insights behind this predictive technology. So we have various modeling nodes. And when it comes to predictive modeling, we typically have 3 types of operations that we can look at: classification, association, and segmentation. We really try to simplify this for you. So if you know that you're looking at classification or a predictive model, we have them all grouped together. So classification is trying to predict if something or an event is going to happen. So examples of this would be, is a high school student at a high risk of dropping out or not completing high school? For marketing, is an individual likely to accept an offer that I'm going to make? Recidivism and looking at crime, is this individual likely to reoffend? So those are typical examples of classification. But I should also point out, segmentation, looking at creating the proper customer segments, or association, market basket analysis, what types of activities or what types of products happen together. I should also point out that it's not just business systems that use predictive analytics. There's a recent announcement between eHarmony and IBM. So any of you out there that have used the dating site, you've actually been matched up with predictive analytics. The engine is actually running with IBM SPSS. So I thought that was kind of interesting. So what I'm going to do is we actually want to go ahead and create a classification model. But because I'm a little bit new to predictive analytics, I'm not quite sure what the best model is for me. So what I'm going to do is I'm going to take the auto classifier and marry that up to my type node here. So in my stream, my data is being sourced. I'm now running into this predictive model. And what's going to happen now is when I run this, and because I've sort of typed out my data, it's actually going to evaluate multiple models for me automatically. So I'm not sure if you caught that in this screen. It actually ran 9 predictive models, and it's surfacing the results for me now. So when I click on this model nugget, I can see here that it evaluated 3 models, one being a C5, one being a Bayesian network, and a neural network as well. So as you do more predictive analytics to become more familiar with these models. But what's important to point out here is that even if I'm a new user or if I'm a statistician, I have the power and ease of use within the tool set. So I knew that I wanted to build a classification model, and it automatically determined what the best model was. In this case, it's C5. And just to digress here for a second, the reason why we identify this as a nugget, this product was originally called Clementine years ago, and the thought was that you've got all this data, you're doing some data mining, and you find this gold nugget. And these are the gems that we really want to capture from our data systems. And that's why we flagged it as a model nugget. So when I click on this now, this is actually telling me for this C5 model, what are the business rules that drive my, my predictor importance. So we actually have the business rules here. So status equals D, divorced, or status equals married in a certain region, and number of trips to the website, and average spend per store. This now indicates what the response is. So this could be the if statements, the case statements, if then else that you may be used to seeing. But what's important to point out is that this was automatically generated for us. Now that's okay with the business rules, but I like this viewer representation a little bit better. So what we have is a decision tree, which basically starts top to bottom on how it processes all the data. So if anyone can think back to watching Price is Right when you were a kid, and if you think back to that game called Plinko, remember you start with a pegboard and you drop the ball at the top, and it sort of tumbles down through all the pegs and lands at the bottom. That's basically what we're doing with this data now. We take our data, drop it in at the top, and it tumbles through all these different nodes and decision trees, and it lands in the appropriate bucket at the bottom. So let's follow this down a little bit to actually see what's happening here. So if I scroll up to the top, I see that certain status is if they're married in a certain region that they're in. As I scroll down, depending on what the path that we take, I can see that we have varying response rates. So certain branches or certain paths within the data, I can see that in this case, 97% did not respond. If I look over to the right a little bit further, I can see that taking this path with estimated income, region, gender, I see that the response rate is 76%. So different nodes have different response rates, and what the predictive model is really trying to do for us is to determine, okay, based on that subset of data that we just used, who is likely to respond. And so I can see here this again in node 32 that we had an 85% response rate based on this path. So again, the lessons that we're learning here is we want to take these insights and apply them to a future data set so we can actually make predictions going forward. So let's take this a step further. Let's shut this down and just see what we're getting, some of the insights that we're getting from these systems now. So what I should point out first is, what happened here with our data. So what I'm going to do now is just show you an output of this data. So I'm going to run this, and everything that you see on the screen so far is exactly the same as the data source that we started with. So the ID, the region, the customer segment, trips to the website, all that data is the exact same as the source node that we started with. The sweet spot here, the real value behind all of this is now, this is the original response column that we have. The model actually created two other columns for us. The first one, this XF response, is the predicted response, and this is the model predicting whether or not that individual would have responded based on the rules that it built within this model. The next step, this next column beside it, is the confidence level. So this reads that this model is 97% confident that this customer with all these attributes is 97% likely to respond. This one is 88% confident that it would not respond. So going forward in terms of our business systems, what we'd want to do is start to act on some of these insights where an individual did respond. Okay, so let's take that and we'll click on OK, and we'll just take this a little step further. So we looked at the response, again, in our data stream. We have it wired up so that we're actually adding two new columns to our data stream here. So what I want to do as well is I want to do an analysis on this data as well to find out how accurate I am. So what I can simply do is double-click my analysis node, wire that up to my model nugget, and when I run this, it's going to tell me how accurate this model is. So I can see here it's telling me that it's correct 88% of the time and wrong 11% of the time, which isn't bad for a model to start with. This was our first pass. So things that we can do are we can possibly change a different statistical model, different algorithms running under the hood, different data sets lend them to be used with different models. We can add more attributes or more columns to our data. to give the more depth to our data, or we can add more records, giving more volume, perhaps to help the model, to help the algorithm find out what some of those key trends are here. But what's important to note is that very easily as a novice user, I don't have to be a statistician. If I know where to look, I can quickly evaluate the accuracy of my model. And again, I can see here that in this case, it's 88% accurate. So one other important piece I should probably point out here is that we want to go ahead and evaluate this model. So we did an analysis. Let's go ahead and evaluate this. I want to look at one of my graphs again. Let's go ahead and evaluate this. So what this visualization is going to do for us is actually running a gains chart. So when I run this, I'll maximize my screen so we can fully see what's happening here, is that this red line represents the traditional approach where if I sent a mail out to 50% of my customers, I would know with certainty what the response rate is going to be. It's basically a one-for-one approach. What this blue line, what this sort of gains chart tells me is that I can be much more strategic now with how I go ahead and target my customers. So this is telling me that with this predictive model, I can send it to approximately 40% of my customers and have 85% confidence that I'm going to be able to cover all of them. So you can see here that we can be much more accurate but much more efficient on how we go about targeting and making offers to our customers. Okay. So let's shut this down. So I just want to recap what we've done. So at this point in time, the key nodes here would be sourcing the data, typing the data, putting it over to a predictive model, and building that predictive model. And so what that's done for us is actually built the rules, those business rules that determine who is likely to respond to an offer. So let's put that into real-world use. So we started with sort of historical information or testing data. What we really want to do now is actually apply that to a new data set. So I'm going to go ahead and use a statistics file again. So in this case, I'm not going to be using my traditional customer data. I'm using new data. So based on the rest of my customers. So again, I built the model. I trained it to understand who to make these offers to. So when I preview this, everything that you have on the screen in front of you now should be pretty familiar with you because it's the exact same data that we worked with previously. If you can guess here, the one difference though is that I don't have that final responded column, right? Because I don't know if they responded. That's the whole purpose of this predictive model. So I have my data. What I need to do, similar as to what I did before, is I want to go ahead and type it out and specify how I want to treat the data. In this case, again, record ID isn't very useful. Everything else is being used as an input. So again, I'm using all these data fields as inputs to throw that into my predictive model. So I've typed out my data, and this is sort of the aha moment where I'm going to take that model that I built previously and drop that on my screen. So now what I can do is take my new data, wire it up to that predictive model, and actually it can generate the output now. So let's look at the table. And so when I run this now, I'm going to have, again, everything that I started with, but at the end now, I don't have the sort of historic responded. I'm actually looking to the model to tell me whether or not what the response rate is. So whether or not they responded or did not respond, and what the confidence level is. So now what I can do is limit my data to those that are going to respond, set my thresholds that I want as an acceptable criteria. This comes back to your business rules. If it's 90% accuracy, 80% confidence, I should say, what is that confidence level that you want to act on? And once I have that, I can now go ahead and export the data. So if I'm writing it back to a database, or if I want to leverage if you're an existing Cognos BI customer, tying that data back to your data warehouse, we have built-in Cognos BI and TM1 nodes as well. So that's the value that we see with IBM Predictive Analytics, is that it's not just about delivering an output and having it sit on your table. We really want to get the information back to your corporate systems, your data warehouses, your data marts, so everyone in the enterprise can act on it. So those of you that are familiar with reporting and Cognos, let's say, at the end of the day, this just becomes another data source. So if you're used to looking at financials or P&L statement or human resource data, we can actually augment and complement that data with another predictive model. So I hope you can see here how quickly we could source data, build a predictive model with very good accuracy, and actually implement the results, tie them back to our data warehouse, and we did that all within 20 minutes. so I didn't have to do any programming here as well. So you can see as a business user or a statistical data scientist or a statistician, you still have the powerful capabilities of a predictive analytics tool from IBM SPSS as well. So Candace, with that, let me send it back over to you, and I'll bring the presentation back up.
Great. Thank you so much, David, for the demo. A few key points I guess we should mention after the demo there is that predictive analytics is a really powerful discipline, and it does provide really quick insight. Looking at this marketing example via SPSS Modeler, we really were able to have access to a more accurate target audience and then take that data to make really key marketing predictions. So really cool stuff there. In closing, I would like to briefly mention that we are offering a 25% discount on training. Also, if you live in the Houston, Texas area, we are having an upcoming complimentary SPSS workshop. So not only do you get to see some of the demo that David did, but it's also a lot more interactive, and it is a complimentary workshop. So please reach out to us. Our email is info@crescointl.com. And let us know. We also do other SPSS workshops across the nation. So if you are interested in doing that, let me know. And we can even set up an SPSS personal virtual workshop for you as well. So thank you, everybody, for joining the webcast today. We do appreciate any and all questions or comments regarding the webcast. Again, please just feel free to email us at the email that you see on your screen, or you can give us a call. Or also visit our website. So this does conclude the webcast for today. We promised predictive analytics in about 30 minutes, and we did that. David, did you have anything else that you would like to add?
No, I'm good, Candace. I'd just like to thank everyone for joining today.
Perfect. Thank you, David, and thank you, everybody, again for joining. Have a great day.